Hello learners, this is Form 4 Mathematics, Matrices and Transformations. We are looking at reflection. By the end of this lesson, you should be able to describe the nature of reflection given the matrix of the reflection. In this lesson, we'll prove the information given in the table below using the formula matrix times object is equals to image, and then I'll give you a trick which you can use without the formula. So the information given is that when an object is reflected through the line y is equals to x, then its matrix of transformation will be 0, 1, 1, 0. And if it is reflected through the line y is equals to negative x, then its matrix will be 0, negative 1, negative 1, 0. And through x-axis, then it will be 1, 0, 0, negative 1. And through y-axis, it will be negative 1, 0, 0, 1. So if we start with the first one, which is y is equals to x, and then we use these points, that is A at 0, 1, B at 1, 0, C at 0, negative 1, and D at negative 1, 0. Then we use the mirror line, which is y is equals to x, that is the mirror line. This means that A will be reflected onto B and D will be reflected onto C. So if we use the formula matrix times the object, we should get image. Then this will mean we take a 2 by 2 matrix A, B, C, D multiplied by the object coordinates, and our object here is A and D. So we have A, which is 0, 1, and D, which is negative 1, 0. So this should give us the image matrix, which is B, 1, 0, and C, which is 0, negative 1. So first row multiplied by the first column will have A multiplied by 0, which is 0, plus B multiplied by 1, which is B, and this will be equal to 1. Then we have A multiplied by negative 1 and B multiplied by 0, so we have negative A plus 0 is equals to 0. This implies that A is equal to 0. To get CD, we take the second row. So the second row by the first column will get a 0. So we have C multiplied by 0, which is 0, plus D multiplied by 1, which is D, and this will be equal to 0. So the value of D is 0. Now we have C multiplied by negative 1, which is negative C, plus D multiplied by 0, which is 0, and this will be equal to negative 1. And if negative C is equals to negative 1, then C is equals to 1. So the matrix here is A0, we have B, which is 1, C negative 1, and D, which is 0. We can confirm that. So it's 0, 1, negative 1, 0. C is 1, positive. So the matrix in the table given is correct. 1, 0, 1, 1, 0. Now we go to x is equals to negative y, or y is equals to negative x as our mirror line. So we draw the line y is equals to negative x. Y is equals to negative x will be aligned through the origin so we have y is equals to negative x. So our points A, B, C, and D. So we will have A being reflected to D and B being reflected to C. So if we take a matrix of transformation which is A, B, C, D, we multiply by the object coordinates, that is A and B. We'll have 0, 1, B is 1, 0. Then we should get the image coordinates, which are D and C respectively. So we have negative 1, 0 for D and 0, negative 1, that is for C. Now if we multiply the first row and the first column, we'll have 0 multiplied by A, which is 0, plus 1 multiplied by B. So B is equal to negative 1. And then we have A multiplied by 1, which is A, plus B multiplied by 0, which is 0, and this will be equal to 0. So the value of A is equal to 0. Now for C and D, we take the second row. By the first column, we have C multiplied by 0, which is 0, plus D multiplied by 1, which is D, and this will be equal to 0. So the value of D is 0. Now we have C multiplied by 1, which is C, plus D multiplied by 0, which is 0, and this will give us negative 1. So we have the matrix as 0, negative 1 for B, negative 1 for C, and D 0. So it's 0, negative 1, negative 1, 0, and that is true. We go to the mirror line as x-axis. So x-axis is our mirror line, and we have the points A, B, this is C, this one is D. So if x-axis is our mirror line, then A will be mapped onto C, D and B will remain where they are because they are on the mirror line. So we can take the matrix of transformation as A, B, C, D. Then the object coordinates, we take A, which is at 0, 1, and then we take one of the points, that is D or B, which is lying on the mirror line. So I can take B, which is 1, 0. So this should give us the image matrix, and the image matrix will be C and B respectively. So C is 0, negative 1, and B will remain where it is, that is 1, 0. So take the first row by the first column, A multiplied by 0, 0, B multiplied by 1, B, which is equal to 0. The first row, the second column, we have A multiplied by 1, A, B multiplied by 0, 0, so A is equal to 1. The second row, by the first column, 0 by C, that is 0, and 1 by D, that is D, and this will be equal to -1. Then we have the second column and the second row, which will give us C by 1, which is C, D by 0, which is 0, and the value of C will be equal to 0. So this matrix will be given as 1, 0, 0, -1. So we can also confirm that, which is a x-axis, and that is true. Now we go to the y-axis as the mirror line, and we have the points over here. So that is A, we have B, we have C, and D. So if Y is the mirror line, then A and C will remain where they are, but B will be mapped onto D. So the matrix of transformation being A, B, C, D, then we will take object, which is 1, 0, that is for B, and any of the points A and C. So I'm taking A, which is 0, 1. So this will give us the image matrix, which is D, -1, 0, and A will remain where it is, that is 0, 1. Now we can multiply this and see. So we have the first row, the first column, A plus 0 is equals to -1. Then we go to the first row, the second column will have 0 plus B, which is 0, so B will be equal to 0. Now the second row, first column, C multiplied by 1, C, D multiplied by 0, 0, so C is equal to 0. And now the second row, second column, will have 0 by C, which is 0, plus D by 1, which is D, and this will be equal to 1. So the matrix here will be -1, this one will be 0, C is 0, and D is 1. So that is when Y is the mirror line. Now we look at a way of getting them without the matrix formula. So the first one is 0, 1 and 1, 0. So we have the y-axis at the first quadrant. So this is y-axis. For the first quadrant, we will use so this is a trick you can use without using the formula matrix multiplied by object to give you image. So we have the first quadrant where we will use y is equals to x, and the second one we will use x-axis. This one will be x-axis, and right opposite the first quadrant will have y is equals to -x as the mirror line, and on this quadrant we will have y-axis. We should be moving in the clockwise direction. So if it is y-axis being used as the mirror line, then the matrix of transformation should be 0, 1, these coordinates over here, and the coordinates for this point. So 0, 1 and 1, 0. We can check that from the table and our trick has worked. So we go to y is equals to negative x. So negative x will have this coordinate and the next one, which is here. So the first one should be, this is y is equals to negative x. This was y is equals to x. So we will have the first coordinate here, which is 0, -1, going to this coordinate over here, which is -1 and 0. So we can check that one for y is equals to negative x, and that's true. Now we go to x-axis, and the x-axis is on this side. So we are moving from this coordinate to this coordinate. So we take the first coordinate, this is x-axis. So we take this coordinate over here, which is 1, 0, to make the matrix of transformation for the mirror line x-axis. So we move to this coordinate, which is 0, -1. So we can check for x-axis if the matrix of transformation is 1, 0, 0, -1, and that is true. Now we go to the y-axis, which is here. So we are moving in clockwise direction. So we are taking this point to this point. So for y-axis, we'll have this point, which is -1, 0, moving to 0, 1. So we can check for the y-axis, which is -1, 0, 0, 1, and the trick has worked. I hope you've enjoyed. That is the end of this lesson. Thank you.